Hello and welcome to question 1. I'll try to be as step by step as possible so you can skip to the portions where you need the most help from. Now let's start with step 0. Step 0 is really about collecting information from the question and also doing some prep work. So the questions we want to ask is number 1, is the population normally distributed? And it's written explicitly in this sentence or this phrase over here. The next question we should ask is, do I know the population variance? Further down in the same sentence, you can see that the variance is given. The other numbers, parameters, or variables that are interesting would be the sample of 50 cars and the observed sample mean is 20.2. So I might just write down all this information somewhere on my foolscap paper, then I don't need to toggle back and forth between question paper and foolscap paper. So let's do that. Now that I've written this down, let's do some definitions. Before I can even call on x bar, I need to define what exactly is x. But in the case of this question, it has very nicely defined for us what the random variable x is, so we can skip that step. Now let's move on to step 1. In step 1, we have to write down our null hypothesis, also known as H0, and the alternate hypothesis H1, or sometimes people like to write as H. So what is the null hypothesis? The null hypothesis is something we believe to be true. Usually a claim made by an expert in a certain area, someone who has authority on the subject matter, or maybe just past research data. Now, what is the alternate hypothesis? The alternate hypothesis is usually formulated from new evidence that has just surfaced, or maybe some new study, a new sample that you conducted, and the results don't seem to gel with what we claim to be true in the null hypothesis. From the sample of 50 cars, the average of these 50 cars is actually 20.2, which is lower than 22. So we might have reason to believe that the mean is not really 22. And I also like to write down the level of significance which I'm conducting over here. Again, just so that I can keep everything on the foolscap, then I don't have to look at the question paper anymore. So that's the end of step 1. Let's move on to step 2. Now, step 2 is where we start to conduct the test. We need to assume that the null hypothesis is true, or we need to assume that the population mean is really 22. Working on the assumption that the population mean is 22 means that we can write down this over here, that our sampling mean variable follows a normal distribution whose mean is 22 and whose variance is 36 divided by 50. Then next, we're going to start to conduct our tests. Now, in the H2 Math syllabus, we're only doing a test on population mean, which means we're only going to do the Z test. So the next step is to convert our X bar variable into a Z variable. Convert the X bar variable to the Z variable, you need to use this formula over here. So the Z variable is also known as the standard normal variable. Now we can move on to the next step, which is step 3, I think. Now in step 3, there are 2 methods of doing this. Method A and method B. I'll first be going through method A, which is to use the test statistic Z and the critical region. The other method is method B, which is to use the GC and produce the p-value and compare it against the significance level. Now these 2 methods will lead you to the same conclusion. In fact, they are the same thing, just different sides of the coin. So let's look at A. How do we use the test statistics and what exactly is it? It's a small x bar and a big x bar first. What is small x bar? Small x bar is one sample mean, right? I took 50 cars and averaged out their speed, and that sample mean is 20.2. Now, if I were to continue taking samples of different 50 cars from the entire population, and I were to do all possible subsets of 50, that will actually give out the distribution of capital X bar. So capital X bar represents all possible sample means. Now, small x bar is just one observed sample mean, and it is this one observed sample mean that will produce one observed Z value. I've done this beforehand, and let me just put in the value. This is our Z value. To answer what is a Z value, I have to rely on this sketch of a bell curve and the diagram below. If this is my mean, if I were to move one standard deviation to the left and one standard deviation to the right, this actually captures 0.68 of the area under the graph. Right, the total area on the graph is 1. Okay, if I move to 2 standard deviations to the left and to the right, this total area will be 0.95 or 95%. Okay, and 3 standard deviations will be 99.7%. So the Z value is literally counting how many standard deviations are you away from the mean in a standardized normal distribution curve. Negative 2.213 will mean that, okay, I'm about 1, 2, and negative 2.2 around here. The next question to ask is, from the significance level of 0.05 or 5%, where is the Z value? To do that, we need to use our graphing calculator. And from the graphing calculator, we need to pull up the inverse norm function. To access that, you need to press second, and then go to vars, which will land you in the distribution menu, and then go to number 3, inverse norm. Okay, and what I want is I want 5%. Since I'm testing for less than the population mean, I'm looking at 5% on the left tail, and the Z value is negative 1.6449 phi SF. Negative 1.6 is around here. Okay, and I'm going to call this Z critical. Why is it called Z critical? Is because this denotes the critical region, the area under the graph over here in orange is 5%. It means that there's a 5% chance or less your observed sample data will produce test statistics here. And in that case, our Z was actually produced inside the critical region, which means it was very unlikely for a population that has a mean of 22 to produce a sample of 20.2. In this case, we will reject H0. In step 4, we will write down the concluding statements to finish up our question. The question did not just ask for whether or not to reject the null hypothesis, but also to give an answer to, did the security guard overstate the mean? So we need 2 sentences to answer this question. We can say that since our test statistic Z, the one in pink, has fallen within the critical region, which is in orange, then we should reject H0 at the 5% level of significance. Answer whether or not the security guard overstated the mean. So there is sufficient evidence to conclude that the security guard has overstated the mean. So this will be good enough to end the question right here. But I'm going to go through method B, how to do step 3 again, but just using the graphing calculator. In step 3B, we attempt the question again. We will use the p-value and compare it with the level of significance. And you find that this method is much shorter, is lesser prone to careless mistakes, and it seems far more superior than method A. Then why do we learn method A? Well, that's because method A actually is more visual, requires you to sketch out where is the critical region, and questions are known to be phrased in such a way that they force you to do method A. So I always believe that it's good to learn method A first before you use method B. So let's take a look at how to operate the GCs, what buttons to key to get this p-value. To access the z-test, you have to go to the stat button. Clicking on the stat button will land you in this page, and then you want to move left to the tests tab. Under the test tab, you want to get to z-test, which is number 1. Now, in the z-test, we are not going to use data. Right, on top, you can see there's data and stats. In this case, we're going to use stats. Right. First of all, mu0. Mu0 is the value of the population mean assumed under H0. That's 22. And over here in the next step, this is where a lot of students make careless mistake, because what they're asking for is the standard deviation, not the variance. So don't key in 36, key in the square root of 36. And then here, small x bar will be the observed sample mean, 20.2. Our sample size is 50, and we're testing for less than the claimed population mean, and click on calculate, and this is your p-value. In fact, using the graphing calculator also gives you the z value, and then you find that, wow, this is so much better than doing it the other way, and I agree. Let's write down our concluding statement using the p-value. Welcome back. So let's look at step 4b. How do we conclude using the p-value and the level of significance? The p-value is less than 0.05, which is our significance level. H0 is rejected at the 5% level of significance. And you can also see that using the p-value, the concluding statement is also a lot shorter and sharper. The p-value being smaller than level of significance is actually saying the same thing as the test statistic is inside the critical region. The second sentence is exactly the same. Right? And this is how we do a hypothesis test question. So if you found this helpful, maybe stick around, and we have question 2 coming up. So catch you on the flip flop.